Welcome, focused learners. Picture this. You're sitting in the exam hall. The clock is ticking down relentlessly. You turn the page of your Cambridge physics paper, and it doesn't matter if you're sitting for syllabus 0625, 0651, 0652, 5054, or 9702. There it is, a massive high-value, multi-mark extended question on orbital speed. I bet your heart rate spikes just thinking about it, right? You immediately know the formula. You instinctively reach for your calculator. But wait, stop right there. Before you write down a single number, you need to understand something absolutely fundamental. Most students lose incredibly easy marks on orbital calculations, and it's not because their math is wrong. It's because their exam strategy is fundamentally flawed. In this explainer, we are going to completely transform you. We're going to take you from a student who merely plugs random numbers into a calculator into a strategic mastermind who extracts every single available mark from the examiner's rubric. We are going to build your ultimate master strategy. Let's make sure you never miss out on these crucial exam techniques again.
This right here is the ultimate trap, and honestly, I see it year after year. Let's imagine two typical students taking the exact same 0625 past paper. Let's call them Alex and Sam. Now, Alex looks at this orbital speed question and completely panics. Alex decides the best approach is to write down every single raw physics fact they can possibly remember about space, gravity, and circular motion. It is an absolute overload of superficial breadth with zero analytical depth. There's no structure, there's no clear working, just a massive block of isolated ideas on the page. On the other hand, we have Sam. Now, Sam is a total math whiz. Sam reads the question, punches the numbers into the calculator in about 3 seconds flat, and just scribbles the final numerical answer right at the bottom of the page. Sam completely rushes past the command words and totally misses the strict requirements of the question. So what happens when the Cambridge principal examiner grades these papers? Both Alex and Sam score maybe 1 out of 4 possible marks. It's heartbreaking. Why? Because knowing the physics math simply isn't enough if you don't know how to systematically present it. The examiner isn't just testing your ability to press buttons on a calculator, they are testing your logical reasoning, your precise data interpretation, and your ability to construct a sound theoretical architecture, right there on the page.
Okay, let's dive into this outline. Here is the exact blueprint we are going to follow today to rewire how you approach these exams. First, we'll unpack the orbital speed trap. Then, we'll reveal the method mark strategy. After that, we'll implement the deconstruct, solve, evaluate framework. Then, we'll look at top examiner warnings, and finally, we'll synthesize it all into the perfect answer sequence.
Let's start with Section 1, the orbital speed trap. We really need to lay down the foundational physics elements before we can start building up to those advanced, high-scoring exam techniques.
Here it is, the core principle that absolutely everything rests on. The formula. V equals 2 pi r over t, where v is the average orbital speed, r is the average radius of the orbit, and t is the orbital period. It looks incredibly simple, doesn't it? Just plug and play. But the theoretical architecture of this calculation rests on some incredibly precise definitions. Top candidates don't just memorize this sequence of letters, they understand the underlying causal relationships. For instance, what exactly is r? Is it the distance from the surface of the planet to the satellite? No, absolutely not. It's the distance from the center of the planet's mass to the satellite. That tiny, subtle distinction right there is a classic Cambridge trap that catches thousands of students every single series. And what about t, the orbital period? Usually, the data table gives you this in days or hours. If you just plug days into the formula when the examiner wants meters per second, you've already lost. The assessment objectives for this topic target distinct cognitive domains: your knowledge, your application, and your analysis. When you use this formula, you're actively proving to the examiner that you understand exactly how geometry and kinematics merge within a gravitational field. You have to clearly decode these command words and define these variables in your mind long before your pen ever touches the paper. To truly master this, I want you to start thinking of yourself as the sculptor. When you first read a really complex physics question, you are basically handed a massive, ugly block of raw data. It's a block of ideas, superficial breadth, isolated facts, maybe a highly confusing data table or a tricky chart. Your job is not to just throw that whole block at the examiner like our student Alex did earlier. No, your job is to expertly chisel away all the irrelevant information, to strip away the vague data, and to reveal the masterpiece underneath. The masterpiece is characterized by logical reasoning and precise cross-topic connections. This is where you use proven structures like the Peel framework, point, evidence, explanation, link, to construct your extended responses. You state your point clearly, you provide specific evidence from the data given in the question, you give a detailed physics explanation using your theoretical knowledge, and you link it right back to the specific context of the prompt.
The assessment framework for Cambridge strictly prioritizes this kind of analytical depth over just memorizing and dumping facts. Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the Method Mark Strategy. This is the part where we shift gears from theoretical physics into pure, unadulterated exam mechanics. Now, what's really genuinely interesting about this breakdown is how it completely demystifies the examiner's red pen. Examiners actually award method marks for the process you show, not just a final number you get. Look closely at Step 1, Procedural Framework. The examiner focus here means you literally get points awarded just for using correct terminology and proper headings. If you're extracting data from a text or a complex table, write it out clearly so they can see what you're doing. Step 2 is Systematic Processing. This is where you get crucial marks for clear working and writing down the explicit formula. Think back to our student Sam. If you just write the final answer like Sam did, and you happen to make a tiny invisible calculator error, you get 0 marks. 0. But if you actually wrote out v equals 2 pi r over t and showed your exact substitution of those numbers, the examiner can, and will, give you method marks even if your final calculation is slightly off. Step 3 is Final Presentation. Points are awarded here for a verified answer with the correct units and clear annotation. Standardized units are totally non-negotiable. If the radius is given in kilometers and the time is given in days, but the question explicitly wants meters per second, your step-by-step presentation of that conversion is exactly what earns you the top-tier marks. This is a direct, incredibly valuable insight from the source material, and it is a massive differentiator between a B student and an A-star student. The principal examiner reports consistently highlight that candidates referencing cross-topic connections achieve significantly higher marks. What does that actually mean when we're talking about orbital speed? Well, it means when you're calculating v, you aren't just thinking about a geometry problem with a circle. You are actively connecting it to kinetic energy. You are connecting it to gravitational potential energy. You are linking it to forces and motion, specifically centripetal force. When you can confidently explain in your Peel paragraph that the gravitational force provides the exact centripetal force necessary to maintain that specific orbital speed, you are showing the examiner a true masterpiece. You are demonstrating that you understand the entire theoretical architecture of the Cambridge syllabus, and not just one isolated, memorized equation. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's move straight into Section 3. Deconstruct, solve, evaluate. Consider this your ultimate operational system for surviving the exam room.
This 5-step methodology is the exact sequence that examiners are desperate to see on your paper. Let's walk through it together. Step 1. Identify given information. Read the prompt and literally underline or list out your R and your T right there on the page. Pay intense, laser-like attention to the units. Step 2. Break the problem into logical steps. If you need to convert days into seconds, do not do it silently in your head. Make that a distinct, highly visible step on your page. Step 3. Solve systematically. This is where you write the formula, plug in the identified data, and execute the calculation. Step 4. Check for reasonableness. This is so critical, guys. If you calculate the orbital speed of a weather satellite and your answer is literally faster than the speed of light, you have made a mistake. Take a split second to evaluate if your number makes physical sense in the real universe. Step 5. Make justified recommendations. In higher order questions, you might be asked to suggest what happens if the orbit radius dramatically decreases. You must justify your answer using those causal relationships we discussed earlier.
When you hit the absolute toughest questions on the paper, the ones targeting higher order assessment objectives, you will almost certainly be asked to do a comparative analysis. Imagine a question asking you to compare a low Earth orbit satellite to a high geostationary satellite. You must use this specific checklist to guarantee your marks. First, identify both similarities and differences. Don't just do one or the other, they want the full picture. Second, use comparative connectives. Words like whereas, conversely, or in contrast heavily signal to the examiner that you are actively analyzing the physics, not just describing them. Third, support your comparisons with hard evidence. Don't just generally say one is faster. Use the formula v equals 2 pi rt to mathematically prove exactly why it's faster based on its much smaller radius. Finally, draw conclusions on the relative importance. Evaluating alternatives and justifying your approaches using this exact Peel-aligned checklist elevates your answer from a basic descriptive paragraph to a highly evaluative, top-tier response. Now, let's transition to Section 4, Top Examiner Warnings. I really need you to focus and pay incredibly close attention to this next slide, because this is where those easy, guaranteed marks literally vanish into thin air.
So the crucial point is right here on the screen. These are the top 3 mistakes pulled directly from Cambridge Principal Examiner reports. Number 1, answers are just way too vague. When asked to describe an orbit, students write things like, "It goes around in a circle." That scores an absolute 0. Examiners demand specific physics details. You need to mention the continuous change in velocity despite a constant speed, all due to the constantly changing direction of the vector. Number 2, forgetting strict format and presentation conventions. We're talking missing units, lacking headers, sloppy working that the examiner simply cannot follow. Remember our method marks? If the examiner can't read your logic, they physically cannot award you those method marks. Number 3, responses are not specific to the given context. If the question gives you a data table about a specific probe orbiting Mars, and you just regurgitate a generic, memorized paragraph about the moon orbiting Earth, you lose marks. You must actively interpret the specific data, texts, and tables provided, and draw evidence-based conclusions for that exact context.
Listen to this quote very, very carefully. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This isn't a suggestion. This is a direct directive from the very people who will be grading your papers. When you are writing an extended response, clarifying your assumptions and your limitations is completely non-negotiable. If you are using the letter T in your explanation, explicitly state that T is the orbital period, meaning the total time taken for one complete orbit. Evaluating the quality of evidence requires identifying these definitions and assumptions incredibly early on in your answer. Do not ever assume the examiner just knows what you mean. You have to prove it to them.
We've covered the hidden traps, the core strategies, the analytical frameworks, and the dire warnings. Now it is time for Section 5, the perfect answer sequence. Let's synthesize all of this knowledge into one foolproof, highly structured system that you can flawlessly execute under extreme time pressure.
Let's look at exactly how this builds a completely standardized sequence for processing not just orbital speed calculations, but literally any complex physics problem you encounter. Step 1, identify key elements directly from the text or the table. Step 2, apply relevant principles. This means explicitly stating your formula, V equals 2 pi r over t, and linking any necessary cross-topic ideas. Step 3, execute the analysis with incredibly clear working. Show every step of your substitution. Step 4, verify your results. Run that quick mental check for reasonableness and evaluate any alternative interpretations if necessary. Step 5, present in the appropriate format. Your final verified answer, crystal clear annotation, and the correct standard units. This standardized sequence is how you absolutely guarantee maximal method marks every single time.
And this brilliantly illustrates our ultimate memory hack for the exam room. When you sit down, the clock starts and the pressure is really on. I want you to just write down these 5 letters right at the top of your scratch paper. I-A-E-V-P. Identify, apply, execute, verify, present. This simple, powerful acronym forces your brain right out of that dangerous panic mode and directly into systematic processing mode. It stops you from being Alex, who just dumps a messy block of ideas, and it stops you from being Sam, who rushes recklessly to a final unitless number. It forces you to take a breath, manage your time, and be the sculptor.
So here is my final, most important question to you. Are you ready to stop blindly plugging in numbers and start actually thinking like a principal examiner? You now possess the theoretical architecture and the procedural framework to absolutely dominate these physics questions. But remember, an exam isn't just a test of what facts you know about the universe. It is a test of how systematically and clearly you can communicate that knowledge under pressure. The next time you look up at the night sky, don't just see random stars. See the geometry, the gravity, and the invisible centripetal forces holding it all together. Go out there, look past the raw data, and build your masterpiece. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.